Hello everyone. Hello everyone. Good evening to all of you guys. Very good evening to all of you and welcome in today's session. Hello everyone. Once again, a very good evening to all of you and welcome in today's session. Today we are going to discuss about the continuity and differentiability previous year problem, which means the problem which came into 2020 in February and March month. Okay. The problems which came in February and March 2021 JEE mains problem, we are going to discuss today. Those problems which came in 2000 this year. Okay. Once again, a very good evening to all of you. Yeah. So let's start with the very first problem. Okay. Let's start with very first problem, guys. You can inform your friend and ask them to join. So let's say this very first problem. First of all, they are saying a function which is defined from R to R, a function which is defined in real numbers. F of x, what is f of x? Is greatest integer x minus 1 cos 2x minus 1 by 2 into pi, where this denotes the greatest integer function. Okay, and they are asking about the continuity and discontinuity, whether this function is continuous or it is discontinuous. Okay, at x is equal to 1, x is equal to, okay, or in, let's say, option number 1. In option 1, they are discussing about the discontinuity. Is it discontinued at x is equal to 1? Second, it is discontinued at all integral values of x except x is equal to 1. Is it continuous at x is equal to 1, or is it continuous for every real value of x? Okay. Now let's see. First of all, whenever I see this f of x, let me write this f of x as greatest integer x minus 1 cos 2x minus 1 divided by 2 into pi. First of all, when I look at this function, f of x is combination of two functions, multiple of two functions. One is greatest integer function, second is trigonometric function, right? This if I look at this trigonometric function has no problem, because every trigonometric function is continuous as well as continuous. We are not talking about differentiability, which means continuous. Trigonometric functions are continuous in that given domain. That is cos x. Whatever this trigonometric function is, it is continuous. Now, but this greatest integer function has some problem, which means greatest integer function is discontinuous at each and every integer value of x. Whenever if I talk about this greatest integer function, whenever the function, the quantity which is written inside become integer at that particular value of x, this greatest integer function become discontinuous. Now this f of x has problem when this, yes. So first of all, now, which means at integer value, let's take your x is, I'm taking x is equal to n, an integer. What is n? N is nothing but n is belongs to integer. Okay, where your n is belongs to integer. I'm talking about that integer. If I check at all the integer value of x, then I can comment what is x is equal to 1. X is equal to 1 is nothing but an integer value. If I check all the values of all the integer value of x. Now, first of all, to check the continuity, all we have to do to find, first of all, let the limit, left hand limit at x is equal to integer should be equal to right hand limit at x is equal to that integer value and should be equal to f of n. This is the condition for the continuity, right? Okay, so first of all, let's check about the left hand limit. Let's check about the left hand limit. Left hand limit, we are talking about left hand limit. So first of all, limit x is tending to n negative. And negative, what is f of x? F of x dx, right? Limit. Now this, I'll write limit h is tending to 0, because whenever I'm talking about the left hand limit, I'll be replacing your x as n minus h. Got it? Now this will becomes x minus, look at this function x minus 1. X is replaced by n minus h. So this will becomes n minus h minus 1. Got it? And this second in trigonometric function, that is cos, here we have 2x minus 1 divided by 2. So divided by 2, here we have pi. Okay. Here we have, now 2x will be replaced by n minus h minus 1, and here we have pi. Now let's simplify this one. Limit h is tending to 0, n minus 1, guys, I'm just rearranging n minus 1 minus h, right? So this will become cos. Now if I multiply 2 inside, this will become 2n minus 2h. minus 1 divided by 2 pi. So this is nothing but what? Now, n minus 1, I'm subtracting something from n minus 1. If your n is equal to, let's say, if your n is equal to 5, so n minus 1 will become 4. So n minus 1 minus h, which means I'm subtracting something from 4, which means this value n minus, which will be less than 4, little bit less than 4. Okay, slightly less than 4. So this greatest integer will becomes what? N minus 2. So this will becomes limit h is tending to 0. This thing will become what? This thing will become n minus 2 into this cos. Now h is, if you put h is equal to 0, yeah, I'm writing 2n minus 2h minus 1 divided by 2 into pi. So n minus 1 is nothing but I'm taking n minus 2 outside. When you put h is equal to 0, this will become cos 2n minus 1 divided by 2 into pi. Now, n is nothing but n is integer. That means 2n will become an even value. Every integer multiplied by 2 becomes an even integer, right? And if I that implies 2n minus 1 will become an odd. Yes or no? This is nothing but odd pi by 2. This is nothing but an odd number, odd integer, odd. Yes or no? So sorry, this 2n minus 1 will become odd. So that means I am writing 2n minus 1 divided by 2. Now this thing will becomes what? Odd. So odd pi by 2. Now if I write cos odd pi by 2, odd pi by 2 is nothing but 0. So your left hand limit is comes out to be 0. Yes or no? Odd pi by 2. So this is finally becomes 0. This is nothing but your left hand limit is nothing but 0. Yes or no? Your left hand limit becomes 0. Now our left hand limit becomes 0. Now what about your right hand limit? Let's talk about our right hand limit. Right. Greatest integer x will be replaced with n plus h. So n plus h minus 1. Yes or no? So now cos 2x will be replaced by n plus h minus 1 divided by 2 into pi. Got it? This is nothing but limit n minus h plus 1. This is nothing but the greatest integer of this will become n minus 1, which means the greatest integer n minus 1 plus h is nothing but slightly higher than n plus n minus 1. N minus 1 is nothing but integer. Okay, so you will get and yeah, so this will become n minus 1. Now what this will become? Cos. If you multiply 2 inside, अगर मैं इसको अंदर 2 को अंदर multiply किया तो हमें क्या मिलेगा? 2n plus 2h minus 1, and I am writing this is pi by 2. Again, what we are getting? Limit h is tending to 0, n minus 1 into cos, right? So if you put, yeah, you have 2n plus, if you put h is equal to 0, if you put h is equal to here, what you will get? You will get when you put h is equal to 0. Now use limit h is equal to 0. So this will become 2n minus 1 pi by 2. Again, this thing is what? This thing is odd. So cos 2n minus 1 pi by 2 is equal to 0 when your n is belonging to integer. So again, you are getting 0. That is your right hand limit. Right hand limit is comes out to be 0. Now, what will be the value of the function at integer? Now we have to find f of n, the function value at integer. So this will becomes n minus 1. Yes or no? Because x will be replaced by x is equal to n. Cos 2n minus 1 divided by 2 into pi. So this is nothing but, yes. So this thing is becomes n minus 1 cos 2n minus 1 pi by 2 when your n is belongs to integer. Again, this will become 0. So this is 0. Now we can say this, yeah, we got three value. What is left hand limit? Is equal to right hand limit and is equal to f of n. So these are equal and these are equal to a finite value. Then I can say, yes, this function f of x is continuous at all the integer value. Got it? So which option is correct? Fourth option is correct. That is, this is a continuous for every real x. This is continuous for every real x. Okay. Let's see the next problem. Got it? So if you're having any doubt in this problem, you can drop your doubt in the comment section. Okay, let's see the very next problem. This problem, what we have? We have the number of points at which the function f of x, when x is belonging to R, is not differentiable. So guys, I'll give you 2 minutes. Okay, I'll give you 2 minutes. I request everyone to please solve this problem. Okay, come on, take 2 minutes. Come on, YouTube people. If you see in this one, the yes, modulus function is involved, and we know that the modulus function is not differentiable, where the inside quantity becomes this is your time, guys. Take your time and solve. Okay, take your time and solve. First of all, find the zeros. कोई भी मॉड्यूलस फंक्शन अपनी नेचर कहाँ चेंज करता है? जहाँ पे उसके अंदर लिखी हुई क्वांटिटी जीरो बन जाती है. The quantity which is written inside that modulus function becomes zero, which means first of all simplify this function in the particular range, particular values of function. Come on, guys. Thirty seconds left. Come on, YouTube people, you can say your answer. Anyone with any answer? Okay, guys, your time here. Time's up. Okay, now let's first of all what we have f of x, that is modulus of 2x plus 1 minus 3 x plus 2 plus this quadratic equation. I can factorize this quadratic equation, that is x plus 2 and x minus 1. Okay, now that means now we have to find the values of x at which the individual, the quantity which is written inside modulus functions become 0. So this is what this is becomes 0 at x is equal to minus 1 by 2. This becomes 0 at x is equal to minus 2. This thing will become 0 at x is equal to minus 2 and x is equal to 1. Now, first of all, now we have to open their modulus function. Modulus function opens around the x values of x at which the inside quantity becomes 0. Yes or no? इसके आजू बाजू में क्या होता है? उसके लेफ्ट हैंड साइड में नेगेटिव होता है, उसके राइट हैंड साइड में क्या होता है? पॉजिटिव होता है. Yes or no? So that means now I'll write all these values in the. So first of all, let's talk about this quadratic equation. That is x square plus x minus 2. Because I want to open this modulus function, that means I have to talk about its nature. कौन से इंटरवल में x square plus this quadratic equation becomes positive and कौन से इंटरवल में ये वाली quantity negative होती है. So I'll take the help of Wavy curve method, that is x square plus x minus 2. I can write this one as, that means I can write this one as x plus 2 and x minus 1. If I take the help of Wavy curve method, that is x is equal to minus 2 and x is equal to 1. So now x value which are greater than 1, this quadratic equation will be positive. If you take the any x value between minus 2 to 1, this entire quadratic equation will become negative. If you take any value which is less than minus 2, this quadratic equation will become positive. Okay, now we have this quadratic, the nature of this quadratic equation, right? Now let me write this is f of x again. F of x is equal to modulus of 2x plus 1 minus 3 modulus of x plus 2 plus this quadratic equation, that is x square plus x minus 2. Now let's write down their zeros. This is nothing but x is equal to minus 1 by 2 This is nothing but x is equal to, this becomes 0 at x is equal to -2, and this will become 0 at x is equal to -2, x is equal to +1. Now let's write down this one on the real number. So first of all, I write x is equal to -2, x is equal to -1/2, and x is equal to 1, which means I have to divide this entire function. I can define this entire function in this region, this region, this region, and this region. How many regions? 4 regions. 4 regions. First, when x is less than -2. X is less than -2. I'm talking about x is less than -2. Less than -2, which means I am on the left hand side of every zeros. How many zeros are there? How many zeros are there? There are 3 zeros, and I am standing on the left hand side. When you take any x value which is less than -2, first modulus function will be negative, second modulus function will be negative, and this quadratic equation, I told you, when you take x is less than -2, this quadratic equation becomes positive, right? Positive. So that means your f of x would become on x is equal to less than 1/2. So this modulus function, I can split into 2 parts. -1/2 on the right hand side, this will becomes positive. On the left hand side, it will becomes -2. Whenever the quantity which is written inside modulus function is negative, that modulus function open with a negative sign. So this first modulus function will be opened with negative sign, 2x plus 1. Now, this second modulus function, if you take any value which is less than -2, the second modulus function will be also negative. So again, -3, this will be open with negative. This is x plus 2. Got it? Plus this, if you take any x value which is less than -2, this quadratic equation becomes positive, which means in this interval, this final modulus function, the quantity which is written inside this modulus function is positive. So this will open as it is. Got it? So what it will become, f of x will become -2x minus 1. This will become plus 3x plus 6 plus x square plus x minus 2. When you simplify this one, what you will get? You will get x square. This will become 4x. This will become plus 2x, and this will become plus 3. Is it clear? Everybody, come on, give me a yes or no if it is clear. Absolutely. When your x is less than 2, your function comes up to be, this will be your f of x. This will be your f of x when x is less than -2. Okay, let's put it inside that box. What will happen if you take this interval? When you take x between -2 to -1/2. Now, second case, when your x is -2 to -1/2 in this interval, in this interval. Again, what about this first modulus function? We are extending, yes, in this interval at x is equal to 1/2, we are extending on the left hand side of this 0, 1/2, which means your first modulus function will be, can you tell me? Yes, first modulus function will be negative, opens with negative sign, right? So first of all, your f of x will become minus times of 2x plus 1, okay, minus 3. What about the second modulus function? We are extending in this region. In this region, the second modulus function, the quantity x plus 2 will be positive. If you take any value which is greater than -2, your x plus 2 will be positive. If the quantity which is written inside modulus function is positive, the modulus function opens as it is. So this will be opens as it is, that is x plus 2. Okay, plus. What about this quadratic equation, guys? This quadratic equation. Again, we are standing between -2 to 1. We are standing now. Now look at this one. If you take any value which is greater than -2 but less than 1, any value which is greater than -2, this quadratic equation would be negative. If the quantity which is written inside modulus is negative, the modulus function opens with negative sign. So this will be minus times of x square plus x minus 2. Now, if you simplify this one, you will get minus 2x minus 1 minus 3x minus 6 minus x square minus x plus 2. Okay. Now, when you solve this one, what you will get? When you solve this one, what you will get minus x square. And this one minus 3x minus 2x, this will become minus 6x. And this is 7 minus 2. Minus 6 minus 1, this will become minus 7 plus 2, this will become minus 5. This is when your x is lies between -2 to -1/2. Yes, we got the second definition of the function. What about the third one? Which means in this third region, when you take x value between -1/2 to 1. Let's talk about this third one, the third case. This was your second case. When your x is, when the x is -1/2 to 1, -1/2 to 1, which means, yeah, now talk about this first modulus function. We are on the right hand side. What is the zeros? The factor of this first modulus function is x is equal to -2, and we are standing on the right hand side. We are standing on the right hand side of x is equal to -2. We are talking in this region. And this region, your first modulus function will be 2x plus 1 will be positive, which means the first modulus function will be open as it is. So your f of x will become 2x plus 1 minus 3. What about second one? We are standing here, which means we are standing on the right hand side of x is equal to -2, which means second modulus function opens with positive also, that is x plus 2 plus. What about this quadratic equation? Now we are standing on this. Now this quadratic, we are standing between -1/2 to 1. Now look at this one. This quadratic equation, x square plus x minus 2 will be negative when you take x value which is less than 1, which means the quantity x square plus x minus 2. Now in this, the quantity which is written inside this third modulus is negative, which means this quadratic equation will be opened with negative sign, which is minus x square minus x plus 2. Yes or no? So for final f of x will become 2x plus 1 minus 3x minus 6 minus x square minus x plus 2. So this is comes out to be minus times x square. So 4x, this will become minus 2x, and this will become minus 3. Okay, this is your f of x when your x is between -1/2 to 1. We got our third definition. We got our third definition. Okay, now let's talk about this seventh region when we are x, when your x is greater than 1. When you take x is greater than the fourth region, when x is greater than 1. X is greater than 1, which means we are on the right hand side of every function. We are right hand side of every modulus function, which means every modulus function will be opened with positive as it is. So if you write down function f of x will be what? 2x plus 1 minus 3x minus 6 plus x square plus x minus 2. So you can see this is x square. So 3x, yeah, this will be getting cancelled out. Minus 8 plus 1, this will become minus 7. This is your f of x when your x is greater than 1. So can you define your f of x? Yes, I can define my f of x. Let's write down the f of x. We got the 4 branches. How many branches? 4 branches. First, when your x is less than 2. When your x is less than -2. X is less than -2, we got x square plus x plus 3. X square plus 2x plus 3. We got x square plus 2x plus 3. When your x is lies between -2 to -1/2. The second region, when your x is lies between -2 to -1/2, the function is defined as minus x square minus 6x minus 5. Minus x square minus 6x minus 5. Now, in the third region, when your x is -1/2 to 1. In this region, which function? We have this function. Minus x square minus 2x minus 3. Minus x square minus 2x minus 3. And the last region, when your x is greater than 1, we have x square minus 7. We have x square minus 7. But yes, guys, because yes, I haven't write down the equal to sign. Why? Because we are talking about the differentiability. If you want, yes, you can write equal to sign here, equal to sign here, okay, and equal to sign here. It's up to you. It's up to you. Wherever you can put equal to sign anywhere. Okay. Now we have to find f dash x. The derivative of this function will be what? 2x plus 2 when your x is less than -2, minus 2x minus 6 when your x is less than -1/2 and greater than -2, and minus 2x minus 2 when your x is lies between -1/2 and 1. When your x is greater than 1, it should become 2x. Now we have to take the differentiability at where the function changes its definition, which means we have to take the differentiability at x is equal to -2, right? So what we have f dash x is equal to, let's write down what we have. I'm just writing the previous thing again. Okay, previous thing again in the previous 2x plus 2. We have 2x plus 2 when your x is less than -2. Got it? Now what we have? Minus 2x minus 6. minus 2x minus 6. When your x is minus 2 to minus 1 by 2, and minus 2x minus 2 when you have minus 1 by 2, x 1. When your x is greater than, you have 2. Now we have, now if I want to check the differentiability at x is equal to minus 2, I have to find the left LSD and RSD. So if you put x is equal to minus 2 at x is equal to minus 2, the left hand derivative will be what? When you put x is equal to minus 2 here, 2 into minus 2 plus 2, what you will get? You will get minus 2. But I'm talking about at x is equal to minus 2. Now what will be the right hand derivative at x is equal to minus 2? At x is equal to, yes, you have to put minus 2 here. So this will become minus 2 into minus 2 minus 6. So this is comes out to be what? Minus, yeah, 4 minus 6, this is minus 2, which means your LHD is equal to RSD at x is equal to minus 2. So the function is differentiable at x is equal to minus 2. Yes or no? At x is equal to minus 2. Now we have to, similarly, we have to check at x is equal to minus 1 by 2 and x is equal to 1. Now, got it? X is equal to minus 1 by 2 and x is equal to 1. Okay, just give me a second so that I can add one slide. Okay, the similar thing, we have to add the left hand derivative and the right hand derivative for these two. Okay. Now, at x is equal to at x is equal to minus 1 by 2. X is equal to minus 1 by 2, what will be the left hand derivative? Left hand derivative, which means you have to put x is equal to minus 1 by 2 in this one. Yes or no? So this will becomes, if you put x is equal to minus 1, you will get minus 2 into minus 1 by 2 minus 6. So this is comes out to be what? Minus 7. What will be the right hand derivative? Right hand derivative, again, you have to put x is equal to minus 1 by 2 in this function. 2x minus 2. So minus 2 into minus 1 by 2 minus 2. Right? So this is what you will get. You will get minus 3. So these are not equal. So LSD is not equal to RSD. So this is non-differentiable at x is equal to minus 1 by 2. Similarly, we have to check at x is equal to 1. What will be the left hand derivative? Left hand derivative will be what? You have to put x is equal to 1 here. What you will get? You will get minus 2 into 1 minus 2. What you will get? You will get minus 4. What will be the right hand derivative at x is equal to 1? You have to put x is equal to 1 here because we are talking on the right hand side of x is equal to 1. This function will be used. This derivative will be used. So this will becomes 2 into 1, that is 2. So this is a left hand derivative is not equal to the right hand derivative at x is equal to 1. So the function will be non-differentiable at x is equal to 1. Yes or no? So this one will be what? You can direct non-differentiable at, you can write at x is equal to minus 1 by 2 and x is equal to 1. This is non-differentiable at two values of x. First is x is equal to minus 1 by 2 and x is equal to 1. Got it? Okay. Now let's take this one. I'm giving you 1.5 minutes. Okay, come on, solve it. Again, this is a very good problem. We will use the help of graphs. Okay, now you have 2 minutes. They are saying that this function is defined in minus 3 to 3. Guys, don't forget about this. The interval where this function is defined. You have to talk about only minus 3 to 3. Right? Now you have to find that the number of points where the function is not differentiable. The function is not differentiable where you see a sharp curve. This function will be not differentiable at this one. Got it? Come on, guys, take your time and simplify. Solve this one. Okay? No need to worry about it. No need for hurry. Come on, 30 seconds. Yes, you can solve. Just you have to write down you have to draw the graph. Okay. Anyone? Okay, guys, your time's out. Okay, let's see. First of all, what is your f function given? The function is f of x, that is, you have to take the minimum of modulus x or 2 minus x square. In which interval? When your x is -1, -2 to 2. And you have, when your x, now this is not mod x, this is mod, this is not x, this is mod x. When your mod x is less than 3 and greater than 2, you have to use this function, greatest integer modulus function. Guys, now first of all, tell me the graph of modulus function. This is the graph of modulus function. What is the graph of 2 minus x square? 2 minus x square. First of all, what is the graph of x square? This is the graph of x square. This will be the graph of minus x square. Got it? 2 minus x square, which means the graph is look like this. The graph will be shifted to unit upward side. This will be the graph of 2 minus x square. Now we have to take the combination of these two graphs between -2 to 2, because your x is from -2 to 2. So from -2 to 2, if you draw the graph, let's say this is the graph. So first of all, this is x is equal to -2, x is equal to 2. So the graph will be, when I'm talking about the modulus function, it is 2. Okay, this is x is equal to 1. This is, let's say, y is equal to 2. When I'm talking about mod x, when you put x is equal to -2 here, you will get a 2. So the graph will be here. If you put x is equal to 2, again you will get 2. This is the graph of mod x between -2 to 2. Okay, what about the x is equal to, the graph of 2 minus x square. Now I'm talking about y is equal to 2 minus x square graph. When you put x is equal to -2, x is equal to -2, you will get what? When you put x is equal to -2, you will get -2. So this one, okay? Here, this is -2. So the graph will be starting from here. When you put x is equal to 0, you will get 2, which means at x is equal to 0, you will get this point. This is 0, 2. This is -2, when you put x is equal to -2, you will get -2. When you put x is equal to 2, again you will get -2. 2, -2. So this is your graph look. Can you tell me at this point? Yeah, these will be what? This is x is equal to 1. This is x is equal to -2. Can you tell me at this point? At this point, your x will be what? √2. At this x-axis, when your y is equal to 0. So 2 minus x square when your y becomes 0. So this will become x square is equal to 2, x is equal to plus minus √2. So this will be x is equal to, and this will be x is equal to minus √2. So this is the graph between -2 to 2. The combination. Now you have to take the minimum portion. Let me show you that this is the graph. Got it? This is the graph. So this is your x is equal to 1. They are meeting, both curve meeting at x is equal to 1 and x is equal to -1. This point is called -√2. This point is called -√2, and this point will be called √2. This is your x-axis. This is your y-axis. This is 0, 2. Now you have to take, this is x is equal to -2. Again, you can see this is, this point and these 2 points. Now you have to take which one? Minimum portion. Now starting from between x is equal to -2 and x is equal to 2. Which graph is minimum? So I have to take this graph. This is minimum. After this intersection point, this graph comes out to be minimum. This graph comes out to be minimum. You have to compare the which graph, कौन सा ग्राफ नीचे है, कौन सा ग्राफ मिनिमम वैल्यू अचीव करा है. अगर मैं बात करूं इस x वैल्यू पे, x वैल्यू पे, मॉड्यूलस फंक्शन will give you this value and 2 minus x square will give you this value, which means you have to take the minimum portion. Which function? This is the minimum portion. After this, इस intersection के बाद कौन सा ग्राफ नीचे है? ये वाला ग्राफ नीचे है. तो तुमको जो ग्राफ नीचे है कंपेयर करना कि कौन सा ग्राफ, दोनों में से कौन सा ग्राफ नीचे है. ओके, सो ये वाला जो मैंने आड़ा टेढ़ा बनाया ना, ऐसा नूडल जैसा, ये वाला ग्राफ तुमको कंसीडर करना है. नाउ अगर मैं इसको सेपरेट बनाऊं, यू कैन सी दिस इज लुक लाइक m. Yes or no? This is look like m. So when you take this separately, this is the graph look like. This is the graph look like. Okay, at these two. This is nothing but 1. X is equal to 1. So first of all, you can clear. Now you have to take, this is the graph. Now you have to talk about the second graph. When your f of x is equal to greatest integer mod x. When your x mod x between minus 2 to, sorry, 2 to 3, 2 to 3, which means now you have to, because your function is defined from minus 3 to 3. Your function is defined from if in this interval, your function is defined, obviously. Now, which means if you take the value from minus 3 to minus 2, if you take x value between minus x value between minus 3 to minus 2, your modulus function will be what? Your modulus function will be what? Your modulus function will be greater than 2, obviously. If you take the modulus function, your modulus function will be greater than 2. So modulus function will be what? The modulus function will be greater than 2 but less than 3, in between 2 to 3. Yes or no? Obviously. Let's talk about any value. Let's take minus 2.5. Okay. Let me give you a actual clear-cut idea. When you take, I'm talking about when you take x between minus 3 to minus 2. Any value, let's say x is equal to minus 2.5. This is x is equal to minus 3. This is x is equal to minus 2. And this is x is equal to 0. Any value between here, minus 2.5. If I take the modulus of that value, it will be comes out to be 2.5. If you take x is equal to minus 2.7, so the modulus x of this value will be 2.7. So between, if you take x value between minus 2 to 3, modulus of those values will be just उनका पॉजिटिव. अगर तुम x की वैल्यू -2 से -3 के बीच में ले रहे हो और उसके बाद उसका मॉड्यूलस ले रहे हो, तो मॉड्यूलस करता क्या है? मॉड्यूलस नेगेटिव वैल्यू को पॉजिटिव वैल्यू बना रहा है. तो तुम्हारा x कहां से कहां तक लाई कर रहा है? x कर रहा है -3 से 2. अगर उनका पॉजिटिव इंटरवल कहां से कहां पे लाई करेगा? पॉजिटिव इंटरवल corresponding, the positive interval will be between 2 to 3. Modulus x will be between 2 to 3. Yes or no? The modulus x will be between 2 to 3. And if you take the greatest integer of those values, greatest integer of those values which are between 2 to 3, this will be becomes 2. Greatest integer of those values. Yes or no? 2 से 3 के बीच में किसी भी वैल्यू का अगर तुम greatest integer लेते हो तो क्या मिलता है? Let's say greatest integer of 2.5 is 2. Greatest integer of let's say 2.9. again 2, greatest integer of 2.0001 again 2, which means इस इन सारी वैल्यू को अगर तुम greatest integer ले रहे हो तो greatest integer क्या आ रहा है? 2, which means if you take greatest integer of those value, greatest integer is comes out to be 2. So that means if you take any value between -3 to 2, the greatest integer will be, yes, this one. If you put exactly x is equal to -3, x is equal to -3, the value will become +3. Yes or no? This is -3,3. Yes or no? This is the graph look like. Let me draw this graph. Let me just highlight this graph. Okay. Same thing will be followed. Same procedure will be followed. Let me say same thing, which means if you take any x value, if you take any x value between 2 to 3, between 2 to 3, so the modulus will be again, that is no problem. There should be no problem in this one. अगर तुम x की वैल्यू 2 से 3 के बीच में लाई कर रहे हैं तो मॉड्यूलस x, there is no written, there is no meaning of writing modulus function, because if your x is positive, modulus x will be the same. Modulus x will be 2 to 3. And if you take the greatest integer of those values, if you take the greatest integer of those values which are coming between 2 to 3, the greatest integer will be always 2. अगर तुम्हारा x 2 से 3 के बीच में लाई कर रहा है, उन वैल्यू का ग्रेटेस्ट इंटीजर का क्या बनेगा? 2. If you put x is equal to exactly 3, greatest integer modulus 3 will be 3, which means x is equal to 3, function will become 3. If you take any x value between 2 to 3, the value will be 2, right? Now, if you take any x value between here to here, the greatest integer will be what? This graph. Yes or no? And if you took exactly x is equal to 3, function will become 3. Now you have to check. Now let's go to the function. You have to check the differentiability in this interval, which means you don't have to consider -3 and 3 in the differentiability. You have to consider between -3 to 2. Now if you combine these two graphs, this graph will be look like this. If you take any value between -2 to 3, this will be become value as take 2. So can you check the differentiability? Yes, this function will be non-differentiable. Non-differentiable at, first of all, at x is equal to 2, sorry, -2, at x is equal to -2. Why? Because at x is equal to -2, function is discontinuous. If at किसी भी पॉइंट पे अगर फंक्शन डिसकंटिन्यूअस है तो 100% उस पॉइंट पे फंक्शन नॉन डिफरेंशिएबल होगा. So the non differentiability at x is equal to -2. Second, Yes, at x is equal to 1. This point was what? This point was x is equal to 1. At x is equal to, you have sharp corner. Yes or no? This is x is equal to 1. This is again x is equal to -1. This is again x is equal to 1. Yes or no? So function will be discontinuous at x is equal to -2, -1. This is discontinuous at x is equal to 0, at x is equal to 0, x is equal to 1, and x is equal to 2. How many points? 5 points. If I talk about -3 to 3, between -2 to 3, 5 points of non-differentiability. 5 points of non-differentiability. Got it? First of all, so the f is non-differentiable. The number of points, again, my answer will be 5. Got it? Now my answer will be 5. Got it? Yes, with the help of graph, you can solve this problem. No need to worry about it. Let's check this problem. Okay, let's talk about this problem. Again, I'm giving you 1.5 minutes. Come on, guys, take your time and solve it. You have to tell me the value of a and b. A plus b, yes. Find the value of a plus b. Come on, guys. Anyone? That's saying this function is continuous. This is one of the simplest problem, guys. This is continuous. That means it will be, first of all, where you have to check the continuity, where the point where the function changes its definition. The point where this function changes its definition. Okay, guys, your time is up. Now, let me solve this. First of all, which means if क्या तो मुझे ये बता सकते हो कि फंक्शन कहाँ पे अपनी डेफिनेशन चेंज कर रहा है? यस, द फंक्शन इज चेंजिंग डेफिनेशन एट x is equal to -1 and x is equal to 1. That means it should be continuous at x is equal to 1 as well as at x is equal to -1. I'm talking about the continuity at x is equal to 1. Continuity at x is equal to 1. So the continuity at x is equal to 1, which means the left hand limit at x is equal to 1 should be equal to the right hand limit at x is equal to 1. For the left hand limit, let's talk about the left hand limit. The left hand limit at x is equal to 1. For left hand limit, which means the portion which consists x less than 1. So x less than 1, I have to take this portion, right? I have to take this portion. So that means the limit x is tending to 1 negative. I have to write what this is, modulus of a x square plus, which means you have to put x is equal to a here. So this will becomes ax square plus bx plus x square plus x plus b. Yes, ax square x plus b. Now we have to put x is equal to a here. So this will becomes what? A plus 1 plus b. This is the left hand limit at x is equal to 1. Now what about the right hand limit at x is equal to 1? Which means your limit x is tending to 1 positive, the right hand side. That means x will be replaced with 1 plus h. Let's talk about this one. We have this sine x plus sine x pi. So this will become sine pi x will be replaced by 1 plus h. So this is nothing but this comes out to be limit h is tending to 0 sine pi plus pi h. Sine pi plus pi h, can you tell me in which quadrant? Pi plus pi h angle will be in third quadrant. It will be in third quadrant. So in third quadrant, sign is negative. So I'll write this is comes out to be limit h is tending to 0, sign pi h negative. When you put x is equal to, when you put x is equal to h is equal to 0 here, this is comes out to be 0. So that means if this function is continuous, so the function is, so the function is continuous at x is equal to 1, that means your left hand limit should be equal to the right hand limit. That means the modulus of a plus b plus 1 is equal to 0. Can you tell me at which value? Yes, this means, can you find out the direct value? Yes, if this modulus function is 0, that means when a plus b plus 1 is equal to 0, that means a plus b is equal to nothing but -1. This is your answer. This is the final answer. There is no need to be worried about this. This was the one of the easiest problem. A plus b is equal to -1. A plus b is equal to -1. Got the answer? Clear, guys? Everybody? Okay. Let's move to the next one. Yeah, this one. Again, this is one of the most problem. So, yes, I'm giving you 2 minutes for that because it needs more time. Okay. Okay, I'm giving you 2 minutes of time. Solve this one. This is, you can say, one of the best problems. Okay, easy one, not the different one. Only small concept will be used. Small concept will be used. Okay. Come on, you have 2 minutes. Just try to solve it. Okay, guys. Come on. Yes, this is the fractional part. Yes, this is nothing but the fractional part function. This is the fractional part function. This is the greatest integer function, right? They are saying this function is continuous at x is equal to 0. Then you have to tell me the value of alpha. So if you guys, if you look at the option, second option says no alpha exists. No alpha exists. That means there is a possibility that function might be discontinuous. If a function is discontinuous, then you have to tell me the value. That means you don't have to do anything. This is just the limit problem. लिमिट का प्रॉब्लम है ये, मतलब ये फंक्शन की लिमिट निकालनी है, ये फंक्शन की क्या करनी है, लिमिट निकालनी है x इज इक्वल टू 0 पे. यही तो इनडायरेक्ट चीज है. Come on guys, you have the 10 seconds. Okay guys, your time is up. Come on guys, focus here. This is one of the very good problem, guys. So first of all, let me tell you small story. That means first of all, this function, they are saying function is continuous. Continuous means that the limit x is tending to 0, f of x should be equal to the function value at x is equal to 0. Yes or no? And this limit x is equal to 0 is nothing but I can split into two parts. That is the left hand limit at x is equal to 0 should be equal to the right hand limit at x is equal to 0 should be equal to f of 0. Yes or no? Okay. Now, first of all, that means limit x is equal to limit x tending to 0 f of x. That means what is f of 0? F of 0 is nothing but the alpha. जो भी तुम्हारी लिमिट की वैल्यू आएगी वही क्या बनेगी, अल्फा बनेगी. इसका मतलब इनडायरेक्टली पूछा क्या है, इनडायरेक्टली पूछा है कि तुमको इस फंक्शन की लिमिट निकालनी है व्हेन x is tending to 0. Yes or no? Now we have to find the limit. We have to find the limit x is tending to 0 cos inverse 1 minus fractional part x square sin inverse 1 minus of fractional part x. Yes or no? 1 minus fractional part x upon fractional part x minus fractional part x cube. बड़ा बड़ा, yes, क्वेश्चन ही बड़ा है यार. upon fractional part x minus fractional part x cube. So before solving this thing, we need to know about what is the fractional part. X is tending to 0, which means if I talk about the left hand limit, that means limit x is tending to 0 positive. When your x is 0 positive, that means we are talking about a very small positive number, very small positive x, very small positive x. That means your fractional part x will become x when x is greater than 0, very small positive number. Fractional value, yes or no? X is positive, 0 positive, which means I am x is 0 positive का मतलब क्या है कि x की वैल्यू 0 से थोड़ी सी बड़ी है, दैट मींस x की वैल्यू क्या फ्रैक्शनल है. इसका मतलब क्या है कि देखो, अगर मैं x की वैल्यू 0.2 लेता हूं, फ्रैक्शनल पार्ट ऑफ 0.2 कम्स आउट टू बी 0.2. अगर मैं फ्रैक्शनल पार्ट 0.001 लेता हूं तो सेम वैल्यू निकाल के देता है, यस और नो? 0.01. अगर तुम्हारा x बहुत छोटा है तो फ्रैक्शनल वैल्यू आउटपुट में क्या देगा? सेम जो तुमने इनपुट डाला है वही तुमको आउटपुट में मिलेगा. कब मिलेगा? जब तुम्हारा x बहुत ही छोटा है. Yes or no? When your x is tending to 0 positive, you can write fractional part x as x. Fractional part x will become x. Now, what will happen if your x is tending to? Obviously, we are talking about the left hand. Sorry, this was of right hand limit. We were talking about the right hand limit. Okay, we were talking about the right hand limit. अब अगर तुमने लेफ्ट हैंड लिमिट की बात करूं 0 नेगेटिव, विच मींस अगर मैं बात करूं लेफ्ट हैंड लिमिट का, तो क्या होगा? लेफ्ट हैंड लिमिट में क्या होगा कि तुम्हारा x क्या है? 0 नेगेटिव, विच मींस x इज वेरी स्मॉल नेगेटिव नंबर, लेट्स से -0.001 और -0.02 -0.3. अगर तुमने उस चीज का फ्रैक्शनल पार्ट, सो कैन यू टेल मी फ्रैक्शनल पार्ट 0.02 इज नथिंग बट -0.2 इज नथिंग बट is come out to be 0.8. Fractional part of -0.3 is nothing but 0.7. That means if you take fractional value in this interval, अगर तुम्हारा x बहुत ही नेगेटिव में बहुत ही छोटा है तो फ्रैक्शनल पार्ट क्या बनेगा? 1 plus x. When your x is less than 0, very small. Yes or no? So this will become. Now these two information we will use. Okay, these two information we will use. Now, first of all, now let's talk about the left hand limit. Sorry, you can talk about the right hand limit because we discussed the right hand limit first. So let's discuss about the right hand limit. Right hand limit क्या होगा? Right hand limit, that means your x will be replaced with yes, 0 positive. Limit x is tending to 0 positive. Let me write this function. That is, now in this one, your fractional part x will be x. Yes or no? This information will be used. So your function is what? Cos inverse. This will become 1 minus x square sine inverse 1 minus x upon x minus x cube. So first of all, yes, you can take x common. If you take x common, this will become 1 minus x square. अब एक काम करो, x is tending to 0 positive. That means अब किस को प्रॉब्लम है? We have three function individual. This function and numerator में भी 2 function है. किस को x is equal to, when your x is tending to 0, किस को प्रॉब्लम है? x जब 0 की तरफ टेंड कर रहा है तो किस को प्रॉब्लम हो रही है? This function has no problem. If you remember, let me show you one more property. That is, limit x is tending to a, f of x into g of x. You can write down that limit x is equal to f and limit x is tending to a g of x. तुम individually दोनों पे limit apply कर सकते हैं. So first of all, I am splitting this thing. Limit x is tending to 0 positive, cos inverse 1 minus x square upon x. Okay, and I am writing this is sine inverse 1 minus x upon 1 minus x square. Or you can write limit x is tending to 0 positive. So if you apply limit here, if you put x is equal to 0, what you will get? You will get in numerator, you will get sine inverse 1 upon 1 minus 0. So sine inverse 1, at which angle sine becomes 1? This will become pi by 2. So this is nothing but this value will become pi by 2. So finally, this is limit x is tending to 0 positive, pi by 2 into cos inverse 1 minus x square upon x. When you put x is equal to 0, this is becoming 0 by 0 form. This cos inverse is becoming 0 by 0 form. Yes or no? 0 by 0 form, because cos inverse 1 is at x is equal to 0, which means when your angle becomes 0. Now we have to apply L'Hopital rule. L'Hopital rule. Now we have pi by 2 outside. Limit x is tending to 0 positive. Let's write down pi by 2 here. When you apply L'Hopital, what will be the differentiation of cos inverse? Differentiation of cos inverse will be minus 1 upon root 1 minus x square whole square. Got it? And the differentiation of 1 minus x square is minus 2x. Okay. And the differentiation of this denominator, I am writing 1. Okay. Now what this thing will become, limit x is tending to 0 positive, pi by 2. You can say this minus will become plus. You have 2x upon square root. When you open this, yeah, we have 1 minus. If you open this square root, what you have 1 minus x square whole square. This will become 1 plus x to the power 5 minus 2x square. So I'll write here 1 plus x to the power 4 minus 2x square. This is nothing but when your x is tending to 0 positive, this 2 getting cancelled out. You have pi x upon what you have, this one. This is, you have 2x square minus x to the power 4. Got it? Now if you take, yes, you can take this thing. I can write limit x is tending to 0 positive, pi x upon, you can take x common from denominator. When you take x square common from this inside thing, so this is comes out to be 2 minus x square. So this x getting cancelled. When you put x is equal to 0, this will become pi by root 2. This is the left hand limit. This is the left hand limit, is x is equal to pi by root 2. Now we have to check the right hand limit. The right hand limit, which, sorry, left hand limit. This is the, yeah, this is the right hand limit. What will be the left hand limit? Left hand limit is nothing but when your x is tending to 0 negative. In this one, your fractional part function become 1 plus x. 1 plus x. So what will be the, yes, fractional part become 1 plus x. Now you have to write down the function again. Limit x is tending to 0 negative. So this will becomes what? This will become cos inverse 1 minus, this is cos inverse 1 minus, you have what you have? You have fractional part x square. Yes, fractional part x will be replaced 1 plus x. So this will become 1 plus x whole square. 1 plus x whole square. Got it? Sine inverse 1. This 1 minus fractional part x, it will be replaced with 1 plus x minus 1 plus x upon 1 plus x minus 1 plus x whole cube. Got it? Now this thing we will limit x is tending to 0 negative. This, if you simplify this one, this will become cos inverse 1. If you, yes, you can open this bracket. When you open this bracket, what you will get? You will get, yeah, this. Let me write again. 1 minus of 1 plus x. Let me write here. If you open it, 1 minus 1 plus x square plus 2x. Yes or no? This thing becomes sine inverse minus x upon, you can take 1 plus x outside. What you will get? You will get 1 minus 1 plus x whole square. Got it? Now, limit x is tending to 0 negative. This will become cos inverse. This 1 getting cancelled, you will get minus x square minus 2x. Sine inverse minus x. Sine inverse minus x, you can write minus of sine inverse x. Yes or no? Upon 1 plus x and 1 minus 1 plus x whole square. So guys, when you put x is equal to 0, these two has no problem. That means you can split into 2 parts. Limit x is tending to 0, cos inverse minus x square minus 2x upon 1 plus x. Limit x is tending to 0. This will become sine inverse x upon this, because I'm taking this negative sign. मैं ये negative sign को denominator में ला रहा हूँ, तो इन दोनों की जगह flip हो जाएगी. तो ये बनेगा 1 plus x whole square minus 1. So guys, remember this thing is what? When you put x is equal to 0, you will get what? Cos inverse 0. So this will become cos inverse 0. Cos inverse 0 is nothing but cos inverse 0. Can you tell me any value? Yes, pi by 2. Absolutely. So this thing is become what? Pi by 2. So this is limit x is tending to 0 negative. This is comes out to be pi by 2 sine inverse x upon, when you open is, when you, yeah, now you can open this square. So this will become 1 plus x square plus 2x. Yes or no? Minus 1. So this is nothing but limit x is tending to 0 negative pi by 2 sine inverse x upon, these two getting cancelled out. When you take x common, this will becomes x plus 2. Okay. Now, when your limit x is tending to 0 negative 0, this will become 1. Yes or no? So this will become pi by 2 into 1 upon 0 plus 2. This is pi by 4. This is left hand limit. So that means I can say your right hand limit is not equal to your left hand limit. Your left hand limit, that is pi by, what was your right hand limit? Right hand limit was pi by root 2. What, this is not equal to pi by 4, which means there is no alpha exist. That means no value of alpha exists. Which option will be correct? No value of alpha exists, which means the second option. There is no such alpha exists for which this function might become continuous. Why? This is a, yes, non-removable discontinuity. This is a non-removable discontinuity. Absolutely, because your left hand limit is not equal to right hand limit. This is non-removable discontinuity. Okay, clear guys? Awesome. So guys, this is for you as a homework. You can take this one as a homework. Again, this is a good problem. All these problems came in yes, 2020-21. JEE means 2021. Okay guys, so that's all for today. That's all for today. Okay, I request everyone to please, if you're having any doubt, you can post your doubts in the comment section. Okay, thank you guys, thank you everyone.